You know, it's easy to look at a 3D model and think that's the end goal, but really, it's just a static picture. A true digital twin, that's something else entirely. It's a living, breathing replica of a physical asset. I'm Mel Torres. Let's get into what's next for the future of AECO. So, how do we bridge that massive gap? Well, today, we're going to build a high fidelity digital twin right from the ground up. We'll explore the core principles that turn a simple model into an intelligent tool that can actually make decisions. Let's dive in. The Digital Twin Consortium really nails it with this quote. It all comes down to relative location. I mean, think about it for a second. The performance of a pump isn't just about the pump itself, is it? It's about how far it is from a cooling unit, how it connects to the power grid, and whether a maintenance crew can even get to it. It's that whole web of relationships, all built on location, that makes a digital model truly powerful. So, here's how we're going to break this down. First, we have to lay the foundation, figuring out what actually matters and how to measure it. Then, we'll look at the incredible tech we use to capture physical reality. After that, we'll get into how we organize that mountain of data. And finally, we'll look ahead to the really exciting part, the spatially intelligent future. All right, let's start at the very beginning. Every single successful project, I don't care if it's digital or physical, it starts with one question. What are we measuring and why? Because without the right metrics, your digital twin is just a super expensive high res rendering. It's a pretty picture, sure, but it has no real purpose. This brings us to a really fundamental concept, and a shout out to Dr. Pingbo Tang at Carnegie Mellon University for this framework. It's the difference between direct and indirect measurement. Now, direct measurement is, well, it's exactly what it sounds like. You want to know the temperature in a room? You use a thermometer. Simple. Indirect measurement, though, is where you have to be a bit of a detective. You can't just stick a thermometer in a project to measure risk, right? But you can measure clues, like safety incidents or material delays, to figure it out. Let's make this real with something we all know, an HVAC system. A direct measurement is easy. You put a thermometer on the wall for the temperature. You read the energy meter. You could even survey the people in the building to ask if they're comfortable. But what about something like energy efficiency? You can't just measure that with one device. You have to measure how much energy is going in and then compare it to the system's output. See? That's an indirect measurement. So, how does this all tie into a big construction project? Well, we basically track four key pillars. Productivity, are we on schedule? Safety, is the site safe? Are we tracking near misses? Quality, is the work up to spec? How many defects are there? And of course, cost. Are we on budget? A truly high fidelity digital twin has to be built from the start to answer these four questions. Okay, so now that we know what we need to measure, the next logical question is how we actually do it. And this is where we shift from abstract metrics to creating concrete models, pulling data from the real world to feed our digital twin. And honestly, the tools we have at our fingertips today are just mind blowing. Let's look at two of the heavy hitters, terrestrial laser scanning, or TLS, and photogrammetry. If you need a super detailed, millimeter accurate model to check your design and as built, then TLS is your go to. But if you just need a quick daily snapshot of a site from a drone to monitor progress, then photogrammetry is absolutely perfect for the job. And just to give you a sense of the sheer scale we're talking about, a modern scanner, something like a Leica RTC 360, can capture 2 million data points per second. Let that sink in. In one spin, it creates a point cloud so incredibly dense, it's practically a photograph. This raw, high fidelity data is the very bedrock of our digital twin. Okay, so we've got our metrics, we've got this flood of amazing high quality data, but data without organization is just noise. So the next and absolutely crucial step is taming this day-to-day luge. We have to turn millions of points and thousands of files into something you can actually use, project intelligence. And here is exactly why that organization is so critical. A study by Autodesk and FMI PlanGrid found that a staggering 52%, more than half of all rework in construction, is caused by poor data and miscommunication. We're talking about billions of dollars just wasted, all because teams are not working from a single source of truth. The industry's answer to this chaos is the Common Data Environment, or CDE. It's even been formalized in the international standard ISO 19650. And look, a CDE is way more than just a Dropbox folder. It's a defined process, a single source of truth for the entire team, making sure everyone has the right data at precisely the right time. The real beauty of the CDE is its simple, structured workflow. It works like this. A designer is working on a model. That's the work in progress state. When it's ready for a review, they move it to shared. Now, the engineering team can access it. Once it's approved and validated, it gets moved to published, and that becomes the official version for the construction team. It's this controlled, step by step process that prevents that massive 52% rework problem. And that brings us to the final and most exciting part. We've defined our metrics, we've captured reality with unbelievable fidelity, and we've organized it all in a CDE. Now, we put it all together. We activate our data and build what we've been aiming for all along, a truly intelligent digital twin. So, what exactly is a spatially intelligent digital twin? Well, it's a virtual model that doesn't just show you a building. It understands the building. It knows that a specific water pipe is running right below a critical electrical conduit. It can process those spatial relationships, giving you a complete holistic view of the entire system. This intelligence has really evolved over time. We started with basic 3D geometric models of, say, a single pump. Then we created spatial models to show how all the pumps and pipes connect. After that, geospatial models put the whole system on a map, giving it real-world context. And now we're combining all of it into fully immersive VR models, where you can literally walk through the project before a single shovel hits the ground. This spatial intelligence just unlocks a whole new world of capabilities. It turns your digital twin from a static model into a dynamic dashboard. You can visually map your assets and see their real-time condition. You can zoom from a citywide view down to a single bolt on a beam, and you can start asking it complex questions like, hey, show me all the pumps due for maintenance within 50 meters of this substation. Now, that is actionable intelligence. So here's the big takeaway. When you bring all these pieces together, the right performance metrics, the incredibly detailed reality capture data, and the organized intelligence of a common data environment, that's when you create something special. You create a digital twin that doesn't just represent reality anymore. You create a platform that actually understands it. So I'll leave you with this final thought. Every single point of data your project generates is telling a story. It's a story about performance, about risk, about opportunity. The question is, are you building the platform that can actually understand its language? Thanks for joining me. If this episode sparked a new idea, share it with a colleague. Make it part of your Monday conversation. Follow for next week's deep dive into the tools and people driving the future of digital twins.